Assalamu alaikum. Today we are going to solve another question on compound interest. Let's get started. The question says Sarah invested £12,000 in a unit trust 5 years ago. The value of the unit trust has increased by 7% per annum for each of the last 3 years. Before this, the price had decreased by 3% per annum. Calculate the current price of the unit trust. Give your answer to the nearest whole number in pounds. Okay, so there's a lot of information here. So what I'm going to do is I'm going to draw a timeline, right? And let's make some points on this timeline. So that's year 1, year 2. I can spread them apart a bit more. Year 3, year 4, year 5. Okay, so for year 1, let me just write year 1, year 2, year 3, year 4, and year 5. Okay, so what I'm going to do is I'm going to work on finding out the multipliers. So the value of the unit trust increased by 7% per annum for each of the last 3 years. So we're talking about year 3, year 4, and year 5. So for this, I'm going to find the multiplier. So that's 100% plus 7% because that's an increase, which is 107%. And that is the same as 107 divided by 100, which is 1.07. So for year 3, the multiplier is 1.07, year 4 1.07, and year 5 it's 1.07. Before this, the price had decreased by 3% per annum. So for this one, the multiplier is going to be 100% minus 3%, which is 97%. That's the same as 97 divided by 100, which is 0.97. So the first year and the second year, the multiplier is going to be 0.97. Okay, so what we're going to do is, in order to find the current value of this unit trust, we're going to do 12,000 times, and we're going to multiply by all of these multipliers. So 0.97 times 0.97 times 1.07 times 1.07 times 1.07. You can also write this as 12,000 times 0.97 squared times 1.07 cubed. You could also use the year on year method, so you could work out at the end of year 1, end of year 2, and so on. This is just going to save us some time. 12,000 times 0.97 squared times 1.07 cubed. The value of this is 13,831 pounds, and because we're dealing with money, we're going to round it to 2 decimal places. So, and 72 pence. There we go. That's the answer to this question, and we've got another question, so we'll go on to that as well. So this question states that Alex invests £4,000 for 7 years. His investment pays compound interest of X percent, so that means we do not know the rate. Okay. And at the end of 7 years, Alex's investment is worth £5,263.73. Work out the value of X. So if I don't know the interest rate, what I can do is work out a multiplier because it's increasing. So I would do 100% plus X percent, and I can't add that. So to change this into a decimal, it would be like 100 plus X divided by 100. And that's what I'm going to use. I'm going to use this fraction as my multiplier. Now the rate doesn't change over the 7 years, so I can just use the method to find compound interest. So amount is P times 1 plus R over 100. Now 1 plus R over 100 gives you the multiplier to the power n. So A stands for the amount, P is the principal, which is the original amount of money that has been invested, which is £4,000. 1 plus R over 100, this whole thing is your multiplier. So in this case it's going to be 1 plus X over 100. Yeah, let me just write this down. And n is the number of years. Okay, so let's continue. So our amount is going to be 4,000. Oh, we have the amount. Why am I writing A? Our amount is here. So that's £5,263.73. That's equal to 4,000, which is our principal, times our multiplier, which is 100 plus X over 100. The reason it's 1 plus R over 100, you can split this up into two fractions. So 100 over 100 plus X over 100, and 100 over 100 becomes 1 plus X over 100. We might do that later on to the power 7. I might be a bit tight for space here. So the first thing I'm going to do is I'm going to divide both sides by 4,000. So that'll get rid of 4,000 on my right hand side. So 4,000 divided by 4,000. This number divided by 4,000. Let's work that out. So 5263.73 divided by 4,000, and I get a really long number. I need to use all of it in order to stay away from rounding errors. 1.3159325 it's not too bad, is equal to actually, okay, I'm going to split this up into this number now. 1 plus X over 100. And I could have used 1 plus X over 100 to start off with. Okay, so in order to now get 1 plus X over 100 on its own, I need to find the 7th root of it, because it's to the power 7. So the opposite is to find the 7th root. So I need to find the 7th root on both sides. Let's see. 7th root of the answer. I'm gonna split my page up, otherwise I'm gonna really struggle with space today. So we were writing in green, we'll switch back to green. So this is 1.04, loads of zeros, 1 2 3 4 5, got 5 zeros and 8 1. That's equal to 1 plus x over 100. So the next step is I subtract 1 both sides. Leaving me with 0.04 and 3 4 5 zeros again. X over 100, and the last step, because x is being divided by 100, to get x on its own, I multiply both sides by 100. The reason I subtracted by 100 in the previous step, sorry, by 1, is to get rid of the 1 on the right hand side. Didn't explain that bit, but now I have. So it'll be 4.00001234581%, or you could, if it was to a particular degree of accuracy, let's say 4%, to 2 decimal places, and that's the value of x. And you can try it. So 4,000 times 1.04 to the power 7 . To double check my answer, I would do 4,000 times 1.04 to the power 7. And the answer from that is 5263.73 to 2 decimal places, which is the same as this. So I know my answer is correct from that calculation. Okay, so we've had 2 questions. The first question was a compound interest question where the rates were changing over the couple of years, and the second question is where the rate was missing. This is how you would solve both of them, and thank you for watching, and hope this helps. Stay safe. Thank you.